Now let's look at another example. Now, this one we're gonna use graphing technology to find out the answers. So this is actually a real problem. It's a physics problem. If then this object is fired upward, it should be straight upward with a speed of 60 meters per second, and then its height is going to increase at first, and then the speed actually it's gonna decreasing until 0, and then we're gonna comes down to the ground. So basically the h is can be modeled as a quadratic function. So if we need to graph this quadratic function, of course we can always do the algebraic way, but it's not that easy as using graphing technology. So now let's go to the GeoGebra. Okay, this is the Geogebra, the main window where you can type in a function right here. So locate this input bar, so you can type in the function. So we note that we still have the function visible here in the background. So negative 4.9, and then x. So we don't use the t, that's the original function, so we always use x in here, and then plus 60 x, and then plus 1.85. Now you don't have to type in y equals, so you just type in the body of your function is actually the expression in terms of x. So enter. So you see the graph doesn't really look nice because the scale, because the y value is actually pretty big, which is height. So we only show up to 6. So we can click this one. So this is the one you can change the scale. So if we drag down and make the scale much bigger, so then you can see the graph. And if you press on the axis, you can scale the axis. And if you press the empty spot, note I used this one. This is a move graph views, and then we need to change decrease the x scale, so then we can see the complete graph. Now of course the graph is actually start from 0 and then until the object falls back to the floor. So any graph more than that doesn't really make sense. Okay, so then look at the question. So it's asking to identify and explain the significance of the intercepts. So let's first look at the intercepts. Now if you look at this point, so if we just zoom in, now you can, this area, this is not the intersect is not the origin, is actually close to the 2. And how can we figure out the value of this y-intercept? And just simply look at the original function. So when you plug in x equals 0, so all this part is gone, and then you got 1.85 left. So the y-intercept is actually equals 1.85. So then we zoom in back again. We don't need to look at that. Okay, so and then we need to find out the x intercept. This is actually by saw. There's a function called a root. So if you type in root, so they automatically show a list of way to do that. So we can choose this one. So then as long as it indicate a function, now in this time the function is actually represented by the f, and then they just use the arrow to shift it to the right, and then they jump to the start x value. So the point is actually after the 12, so we just type 12 as the start value, and then the end x value may be 13, right? So no, it doesn't matter, you can type in 14 as long as these two values should cover this intercept, and then it should work. Excuse me. And then we got the x, the point A actually is the x-intercept, and its coordinate is right here, 12.280. Okay, so that's the x-intercept, and then we can now of course you can interpret the as long as we identify, we can interpret that. First of all, the y coordinate, uh, uh, it's when x when the t equals 0 or x equals 0, means that's initially before the object is fired. That's the height of the object at the moment it's being fired. And then this is the time, right? Because the horizontal axis means the time. So this is the time when height equals 0. So that means after 12.28 seconds, the object actually falls back to the ground. Okay, then let's find out the vertex. So the vertex in this GeoGebra is actually, we use maximum. So if we use maximum, we can just click this one. So again, you need to type in the function f and then use arrow key to shift it to the right. So you should estimate like what's the interval this maximum, the vertex point is. So it's supposed to be between like 5 to 8, right? So we type in 5 and then shift to the right and then type in 8, then enter. Here you go, we got the vertex is 6.12 and 185.52. Now obviously this is the maximum height of this object that can reach, and then the vertex, the x coordinate is the time, so at 6.12 second, so the object is at the maximum height 185.52 meters. Okay, so that's the vertex. And the domain, so we already explained. So the domain of the time is supposed to be 0 to the 12.28 second. And the range obviously is from 0 to the 185.52 meter. That's the maximum height. Okay, so then we basically put everything back here, and then you can also take a look at all the notes.